All right, today's topic is going to be the observer pattern. One more pattern for us to become familiar with. This one is a very important, very frequently used pattern. So it's one that's worth going into a reasonable amount of detail about. Luckily, it's pretty easy to understand. So we're gonna set the scene here. We're going to say that your task is we're hired to use data from some kind of object that collects weather data. And we want to convert it into some number of user interface displays based on the device that the user is using. So we're going to pull information from this weather station. And the weather station has a bunch of different devices for measuring the temperature, the humidity, and the pressure. Then we have an object that just queries the weather station and says, what's the current state of the weather? We then need to parse that and create some kind of display that the user is going to access. So if a user tries to access our weather data object from a phone, we want to create a mobile display for that information. If someone comes in on a desktop, we want to have a desktop display for this weather data. If someone on channel whatever news comes into our weather data object, we want to give them a display for the local news broadcast. Who knows? There could be a bunch of different displays for all of the associated weather data that we care about. So Weather-O-Rama is a company that provides the weather station and that, so we just have to interface to pull the data from that location and then display that data in some way. So you can imagine that the code for the weather data just has getters that is going to query the weather data object and say, what is the current temperature? What is the current humidity? What is the current pressure? We don't have to worry about where we're getting that from, aside from the fact that it magically gives it to us. So there may be some other methods as well. So we need to convert this information into some kind of display for the current conditions of the weather. So we know the weather data class has getters for the temperature, humidity, and pressure. There is a method called measurements changed that is called whenever new measurement data is available. So the weather station will reach out to us and say something has changed, and then we can call the get temperature, get humidity, and get pressure. So we don't need to worry too much about how this happens. It's just going to happen from our perspective for this. But we need to have three different kinds of displays. We want to be able to have the current conditions display. We want to have the weather stats display and a forecast display. You can imagine that this is something like a weather site where you have different tabs or different pages that tell you each of these different kinds of information based on who cares about that. If you click on that tab, you want to display that. But of course, as with everything design patterns, we have to have some kind of expandable, extendable implementation so that as new displays come in, we can just plug and play that new display. I did not mean for that to rhyme, but it did. So there may be some additional display elements in the future that we want to just be able to use. Those who connect to our weather data object should be able to add displays that they care about and remove displays that they don't care about from their custom feed. So turn around to some neighbors and think if you can figure out how we could do this. How if I'm your boss and I tell you implement a solution to this problem where we want to be able to have a current conditions display, a weather stats display, and a forecast display. Come up with a UML diagram that would solve this problem. But note that the user wants to be able to add or remove aspects of this.
It'd be easier to be able to just change or update it. Because you go ahead and change, you thought tomorrow to be something that's actually written. And just to go about it, have to change it rather. Have to change everything. These are just, you don't have on a computer, or a computer, when you can take your apps off of your screen now and put it in the sidebar or whatever. I think that's what it is. No, you're not like completely deleting it, you're just taking it off your screen.
Display the new
Okay, so like you as like a main, like you have to be want to display the resolutions, the editor, you should display the stats or and then there's no others.
in the interface that then the main loader of your skin over it. Grab that new method for the new display.
Yes.
So
Yeah, I agree with the composition.
That's a good idea. Refactoring guru probably has a good solution. So do people at least have a sketch of what they think could work?
The daughter with those.
Here, the measurements, this one has, so based on this, and sense of magician. And you know, there's a people and that information from the street. And they don't have that one, when you have spent. Whether when you have a user class that has two methods, one is have user, one is user. So whenever a user wants to add, we say, I'll use that for this one and provide this information, which are needs to be on this display type.
And then use.
So once we have this information, then we have this class, where it has a user list, and then we push it to the whether to do it that are.
Here's some really good thoughts out there. So let's talk about this. Let's talk about what a first attempt at this might look like. some of the concerns with what might be intuitive, and then introduce the observer pattern and talk about how that works. So here's a first attempt at what this might look like. So we're gonna figure out what are the most recent measurements by the weather data's system. And now we have a current conditions display, we have a statistics display, we have a forecast display. We're keeping track of what each of those displays are, so we're just gonna update them whenever, however we get the new data, we're going to update those. And then call each display element when we need to. So let's take a look at this. Pros and cons. Yeah,
You wanted to remove one of the displays.
yeah, we need some way to remove the displays. But even with just this as it is, what it's trying to do, I feel like there's some issues with this.
I did it only update once. It's not gonna be-
Yeah, we have to call measurements changed over and over and over whenever we want to be able to update them. So we don't really know when the measurements have changed, so we'd have to call measurements changed until something changes. Maybe we call it once every 30 seconds on the fly, and then whenever we get back that something changed and it's different from what's currently being stored, then we call an update.
Is that why there's a user setting in like most weather apps that does that?
Yeah. So there are two different ways. There's a push model and a pull model. The push model says, I'm not gonna update, I'm gonna let you tell me when something has changed. And there's the pull model, when you wanna say, has something changed? And that allows you, the client, control over how frequently you update, because there's no guarantee about the frequency of that update if you're using the push model, and they tell you when something has changed. You're always updating with the most recent data, but it could be quite the load on your CPU or your network. The big issue here is that these updates are changing. So if we're really trying to make this extendable, because we can't extend a new display here without changing this existing code. We can't add new temperature, humidity, pressure, if there's some other piece of data we want to collect. We should probably be encapsulating all of these things into their own classes. So there's no way to add more displays without coming back and editing this code. So because of this, the current conditions display should probably be its own class. The statistics display should be its own class. The forecast display should be its own class. So we're gonna put this on hold for a second, learn about the observer pattern, and then come back and see how we can apply the observer pattern to this problem. So let's first think about how a physical newspaper subscription works. Yes, this is becoming more and more outdated, but just thinking about how this works is a very natural way of understanding the observer pattern. So how does a physical newspaper subscription work? Yeah,
So you go to their office or call them and subscribe,
yeah,
and then they deliver the news every morning or based on your subscription,
yeah,
and then they keep giving you the news until you unsubscribe.
yeah, there's kind of a subscription service associated with this that says, I would like to receive your newspaper. You communicate that, and then it becomes one of many subscribers from the newspaper's perspective, and every day they just go through all of their subscribers and make sure that that subscriber gets a newspaper. From your perspective, you subscribe, you start receiving newspapers, you stop subscribing, you stop receiving newspapers. So publisher goes into business, starts publishing newspapers. You do not get these newspapers because you have not subscribed. You subscribe. You begin getting newspapers as they are published, but not the ones that were published before you started subscribing. Then you unsubscribe, and now you stop getting the newspapers. That's from your perspective as a subscriber. From the company's perspective, each time we publish a paper, we're going to look at the entire subscriber list and send a copy of the newspaper to every subscriber in our subscriber list. So we have two components, we have the publisher and the subscriber. If you can think Digitally, do I have a digital publisher and a digital subscriber? Then you want to use the observer pattern. So thinking about a newspaper subscription is a natural way of understanding when should I apply the observer pattern. Whenever you have a publisher-subscriber relationship between two classes. So let's take a look at some of the details. We have a one-to-many dependency between objects. We have one publisher and potentially many subscribers. When one object changes, all of its dependents need to be notified about that change and updated automatically about that change. So the publisher class has a single field that is a list of all of the current subscribers. Some kind of list, could be an array list, could be a linked list, who knows, some kind of list of the current subscribers. We also need some behavior, a way to field a request from some object that wants to be added to this list of subscribers. We need behavior, some way for an object to remove itself from the current subscriber list, to unsubscribe. And then we need some way of notifying, of communicating something to all current subscribers. So you need all of those components in the publisher class. Inside of the subscriber class, we need something that gets called whenever the publisher's state changes. So when the publisher notifies all current subscribers, eventually that notification is going to get sent to the subscriber class. The subscriber class needs to be listening for that and then grabbing it. When that update is sent, they need some kind of listener object that says, oh, you updated, I'm going to go pull that update. So it looks something like this. We have a one-to-many relationship of the publisher on the left and a bunch of observers on the right. And there's an automatic update that happens basically whenever the publisher says, I have an update. Then it notifies all of its subscribers, I have an update. And then they say, great, and go pull that update. Questions about how this works in general?
This is the same as the official one.
It's kind of the publisher is pushing, I have an update. Yeah, and then you can, the way that you kind of create a push and pull is that you get a notification of a push. And then they actually have to go get the data with a pull. And that can be a way that you can choose yes or no, do I want to go grab that update? So it's a push model if the update is sent along with the notification. Here's the new data, here's the new data. And the pull would be, I'm not waiting for an update, there is no notification system, but there's a way for me to interface with that object that says, has there been an update? Has there been an update? And then you grab the update when it's relevant. But you don't know for sure if you have the most up-to-date information.
So,
Yeah,
then one of them is more kind of expensive or heavier than the other one. If you have thousands of subscribers and everybody's asking for the information, it's gonna be load.
yes, that is certainly a heavy load depending on how frequently they can do that. So you might have some kind of timeout that says, once you ask me, you can't ask me again for 30 seconds. If you field another request or get another request, just hits a wall, and then you take down the wall after 30 seconds and then it gets through. Then you put the wall back up. So you can code things in that way to reduce load. But yeah, certainly there are relevant pros and cons from each the publisher and observer perspective, depending on the entire setup. So the publisher has to think about what's the best for my system, and the subscriber has to think about what's the best for my perspective, and come to some kind of agreement. So here is the UML for the observer pattern. So we just have a subject and an observer. The subject is the publisher in this case. So we have interfaces for each of these subjects and an observer so that there can be different types of subjects and different types of observers. So these can become entire hierarchies if necessary. So we have some kind of concrete subject that has a way of registering a particular observer, a way of removing a particular observer, and a way of notifying all of its existing observers. From the observer's perspective, we can have a bunch of different types of concrete observers, but there's an update that goes and updates based on whether or not there is a notification from the subject that says, I have new data for you. The way that Refactoring Guru does this, I kind of like, it's kind of funny. So there's a store that receives new shipments or new updates. You can imagine that you, as a user, are really interested in getting the newest iPhone from this store when it gets the newest iPhone in stock. The boring way to do it is to go to the store every single day and ask, is the new iPhone in stock? Is the new iPhone in stock? Is the new iPhone in stock? Every single day. And it makes more sense to apply the observer pattern and have a notification where you're on some kind of mailing list. And when the new iPhone comes in stock, you're going to receive an email that says, hey, we have the new iPhones in stock. And then you don't waste the time at going to the store's location and asking over and over, do you have it in stock? It just doesn't waste your time. You wait for the notification that says, now you can do the thing that you want to do without having to ask, is it time to do the thing that I want to do? So that also is a potential place that you would want to use the observer pattern. Questions on the UML? It's pretty straightforward. This one is one of the easier to understand ones, but it's also a very important one because in practice we have lots of observer situations. Lots of waiting for change happens in a lot of systems. Whenever you're waiting for change, this is a good place to be. But we should also talk about some coupling issues. So there's a concept called loose coupling that allows objects to interact without knowing very much about each other. So a standard design principle in object-oriented programming is we want to have loosely coupled designs between objects that interact wherever possible. We don't want to tightly couple these objects such that they have to be aware of each other's internal state at all times. We can notify when something changes and then they are loosely coupled, rather than needing to have access to each other's internal state. Whenever the internal state changes, we will communicate with each other, and that becomes significantly more loosely coupled. So you get some benefits when you have a loosely coupled design, like storage is minimized, communication that has no relevance is minimized. All of this is extra work on a computer, extra bandwidth that we just don't need. In the observer pattern, our subject only knows the interface the observer uses. They don't know what kind of concrete observer they are. We just know that they adhere to one of these observer types, and it doesn't matter. So we don't need to know the observer's concrete class. We don't need to know the purpose of that concrete class. We don't need to know what it's going to use this data for. It would be something like the newspaper requiring you every day as part of the delivery, I'm not gonna hand you this physical newspaper until you tell me what you're gonna do with it. Which is useless information from the publisher's perspective. They just wanna know, are you gonna pay me for this? Yes or no, that's all that matters. And if you pay them up front, it's like, here, whatever you do with this newspaper, I don't wanna know about it. It's not relevant to me. What this allows us to do is we can add new different observer types as long as they adhere to the same observer interface. So you could have a business subscribe to a newspaper. It's exactly the same thing. You give them an address and you physically deliver a newspaper to that address. Doesn't matter if it's a business or a home, or in fact, we wouldn't even need to know if it's an alien. Is it a human that's receiving this newspaper? Irrelevant, they're paying me. Here you go, here's a newspaper. Don't need to know that you're not a human. So we can also swap out observers at runtime and the subject doesn't know. If somebody moves from a physical location, I moved from my house. And the next person who lives there also wants the paper. Does the publisher need to know that a move took place? No. Keep delivering to that same address. It doesn't matter if the person you're delivering it to changed. What matters is someone at that address wants that newspaper. Something happened, the publisher doesn't need to know about it. So this allows you to update the observer code at any time. You can say observer.move and they moved locations. Great, the publisher doesn't know about it. They don't need to know about it. So this also says that we have some other use for our subjects or our observers. We can reuse the subject and observer code because the subject can change without the observer and the observer can change without the subject. So we can plug and play that same observer code or that same subject code in other contexts because they're not reliant on each other. They don't have to move together, they can move independently of each other. So striving for that loosely coupled design is very extendable, very flexible. It allows you to reuse your code a lot more. You don't have to worry about what needs to change in order for me to use this code in this new environment. You can just plug and play because you created abstract tools that aren't coupled to the problem that you designed it for. And that is very valuable and very difficult to learn and implement, but it's a very important principle. So we want to minimize the interdependency. Changes to the subject don't affect the observer, changes to the observer don't affect the subject. So that's kind of the observer pattern. Let's go back to how to apply this to the weather station. Take a couple minutes, think about now that we have an observer, who is the publisher? Who is the subscriber? Could we come up with a publisher-subscriber situation here and go ahead and sketch the UML and see if you can apply the observer UML where you have an interface for subjects, an interface for observers, and concrete subjects and concrete observers. Get back in your groups and see if you can sketch out that UML and what that would look like. These.
What did I do? Just trying to think with the probably gonna be split. So where should we have the that, but there was basically watching the measurement changes, or
Yeah.
they're watching all of this, but I don't.
The measurement.
Would So that how the measurement change class connected to the. You would just be connected to the display class and they'll change each one of them.
Yeah.
But what is, so then where does the content, who does the content interact with? I thought the content has to interact with display, how would it, how display would it want?
Well, you can just, well, because each display class is its own thing. you can do like, I don't know if it's. Like, I don't know, if it's a private class with that big one, so that when they take pictures, they're subscribed to, and then you can update.
The observers looking at this connected to the display interface.
So how they did it was, so they had an editor, trying to make it more interesting, and then picture things.
Are you configuring the structured one?
Yeah,
What is that?
so then,
No, that makes sense. It makes sense to me. I see where you're going, but I feel like I'm having a hard time understanding this. What would kind of be like our publisher? Would our publisher be more? Basically, I'm confused on like what the client is interacting with the most.
this one is saying that it's interactive with the subscribers.
Um,
So then if you want to have the card, just go ahead, which display is it subscribed.
Oh, okay. So the view is that we should have, so that we have to make the subscriber interface and the subscriber concrete. And then is that subscriber concrete can be connected to our display interface, or is it can be connected to, should we make the display interface and the display concrete?
And display.
So like you see how with the subscriber, there was a concrete subscriber and interface with the subscriber that basically interacts with, like, the publisher tells the subscriber interface what it wants and the concrete subscriber makes that happen.
Well, the concrete subscriber will need that like every, like, it's gonna like have that format for every single subscription. But if they want to change that, I think we want.
The concrete what?
Okay, I don't think we want to do them if they want to add anything. It's
So
not
then-
that it's like set to where it has all of these things.
So basically, like,
So then you can just.
are you saying like the 3 different displays, or those are like more of the concrete displays?
Yeah.
Okay. That makes sense. So then we want to have our subscriber interface connected to,
Don't you need this subscriber? Yes.
yeah, because I feel like you'd have to have that because. But actually, you might not need that. But how would you know, I guess? You would have to connect weather change, the measurement change to the subscriber update or the subscriber interface, that'll basically tell it to update it.
Wait,
Or not tell it to update it, but it'll notify the subscriber that it's being updated. And then it goes into the subscriber.
like, it goes into the display and then.
Hmm.
So I have a solution up here, and it's worth kind of taking a look at this and see how it works with your idea. This is not the only idea, of course, but I think something like this will work. And from what I've heard from people discussing, it's very similar to what people are coming up with, which is good. Unfortunately, we are out of time, but we're gonna come back to this tomorrow and finish off exactly what the code for these classes will look like. For those of you who are here today, please do try to come tomorrow because I know Riley, you can't make it. But I will be having a follow-up survey after this lecture, kind of following up the survey that we took at the beginning of class today. So I will figure out what to do with you, Riley, but for everybody else, if you can make it at all tomorrow, that would be great. Okay,
I mean, I can take the survey online, if it's just on Canvas if you
Yeah.
want me to do that.
it would be,
Or do I have to be in person to take it?
you don't have to be in person to take it, but I guess I could have you look at the recording from the start of class tomorrow and then take the survey. But we'll figure out how to make that work. Thanks, everyone.
You